Hey, hello, welcome to my channel. Today we are going to solve this October daily challenge question, longest common subsequence. As you can see, I'm using Mozilla Firefox. You know why? Because on Chrome, I kept running out of RAM. I don't know why Chrome takes so much of RAM. Yeah. Anyway, I'm loving this new what do we call this browser. Okay, so let's get back to the question. So we are given two strings, text1 and text2, and we need to find the length of the longest common subsequence. If there is no common subsequence, we just have to return 0. Okay, a subsequence is a string. We all know what a subsequence is. It's just something in the order. As long as you have the same order, you can choose to keep or remove the characters from a string, and it would still be a subsequence. You can see, for example, here we have A B C D E and we have A C E, and by intuition we could say that the longest common subsequence would be A C and E. So that would be the length of the common subsequence would be 3. This seems like a dynamic programming question, and I'll tell you why. For example, I have a string. uh, let's say this is the string. Let's say x x x x x x, and let's say the second string y y y y and y. Oh, another y is like non-homogeneous. Okay, for example, let's take these two, the first x and first y. I have three cases to move forward. The first case would be when x and y are same. In that case, I could add 1 to the answer, and then I could just check for longest common subsequence in this string and this string. Or if both of them are not equal, what I could do is I could skip this y, and I could consider all of this string and all of this string. Or I could skip out this x. I could consider this whole string and this whole string. So there would be three cases in each and every decision we make might lead us to the most optimal answer. And that during dynamic programming, we would include a little bit of greediness. So we would always choose the case which would give us the biggest answer. Let's start writing the code. Uh, so I'm writing a function, whatever we might call it, recursion. And as I told you, we need to for example, let me get back to that example. So we are always considering the whole string from a particular point. So why don't we recurse based on that point, the starting point? Let me call my starting point s1 and s2, and so def recursion of s1 and s2. As this is a function inside function in Python, uh, the text1 and text2 are already included in it, so I don't have to include them again. So if I reach the end of the string, then for example, even if I reach the end of the string of one string, then the longest common subsequence would not increase any further because you don't have any other characters to compare. So if s1 is greater than or equal to length of text1, in that case I just have to return 0, because there's no way you could compare and further increase the length of this common subsequence. And if s2 is greater than length of text2, the same case again, you just have to return 0. And then, as I told you, we have three cases. So the first case is when both of them are equal. So if text1 of s1 is equals to text2 of s2, in that case my answer would be 1 plus the same function called recursively, but with the next indices. So s2 s1 plus 1 and s2 plus 1. And the other two cases, we just have to choose the maximum out of those two cases. So if none of these satisfies, then we just have to return max of recursion of s1. So in case 1, I would just move my pointer to the second string to one step forward, so it would be s1 comma s2 plus 1. And the other case would be moving the pointer to my first string forward and keeping my pointer to the second string intact. So I would choose the max out of these two cases, and then I would just return it. And then I would call this function, the recursion function, with 0 comma 0. So we have to start considering from 0 comma 0. If I run this, oh, let me run this. Hey, it would work for smaller inputs, but the thing is, if we look closer at our time complexity, for each case we have two cases, so that would be 2 times 2 times 2 times n, so that would be 2 power n. That would be exponential time complexity, and here the constraints given are that 1000. Oh, so the length of text is 1000. 2 power 1000. Oh, 2 power 1000 is humongous. It's even hard. It's too hard to imagine that big number. It's very big. Just forget recursion, it won't work. So whenever we have a recursion, in that case we could use memorization to convert it into a dp, because there would be so many cases we would be calculating again and again and again. So we don't have to do that. We could just use recursion, store that input, store that result, and use that again the next time. So in Python, we could normally do recursion by taking a dictionary, and then just checking if the tuple s1 comma s2 is in d, then just return d of s1 comma s2. Otherwise, calculate all of this. Otherwise, at the end, for this, got to s1 comma s2 is equals to this thing, and then just return. Oh, let me just copy this thing. This is too big to type. Okay, and then do the same thing. Then do the same thing. The enter should have been okay. So I just need to take this thing, equal this thing to this thing, and then just return this thing. So if you're wondering what this recursion thing is, there are so many blogs and YouTube videos you could use to solve this. So now, as I'm doing recursion, my time complexity would be n square, which is very 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 efficient than the 2 power n version. But the thing is, in Python we don't have to do all of this each and every time. So for example, whenever we need to do memorization to any function, all we have to do is use this function lru cache. It's a function inside iter tools in Python, and then you just have to give a limit. So here it's very convenient to use none, but if you're a professional, if you want to make it even more efficient, then the number of cases would be at most n square, because we have two s1 and s2, so there are two possibilities, so n into n. So we could either do as length of text1 into length of text2, or you could just be a man and put none there. And if you just run it, it would still give us the answer. And I really love this function. It saves us a lot of time. LRE cache, you could read about it in internet. And that's it, guys. I'll be back tomorrow with tomorrow's question. So if you like this, just follow along as we solve all questions this month. Thank you.